Hi, and welcome back to another episode of Rachel Teaches Math. As promised, I will deliver some very poor quality videos during this this time that we're out of school with coronavirus. So day 2, I've resorted to infrequently brushing my hair and wearing all monochromatic clothing. Oh, and I did my nails. So that. Today we're going to be focusing on solving quadratics. Now, all the way up until this lesson, we've been doing factoring from standard form, so putting into factor form, going from standard form to vertex form, and then kind of going between the different forms. So when I say solving, now I'm kind of piecing that together. What is the connection between the different forms? Specifically, what is the connection today between factored form and the solution to a quadratic? Well, first we should talk about what does it mean if you have the solution to a quadratic equation. Well, you might hear things like solutions or x-intercepts, which is what you're probably most familiar with, or zeros. Now I'm putting the s in parentheses because sometimes you'll have no real solutions, one real solution, or two real solutions. So what I'm talking about is where it's crossing the x-axis. So x equals q and x equals p. Okay, my nails. All right, so let's specifically look at if I give you something that is in standard form. Now, just as a recap, let's go ahead and factor this. We're going old school right now. Old school. Just found these whiteboards. All right, so I have x squared plus 10x plus 24 equals 0. I'm thinking of the numbers that multiply to be 24 and add to be 10. Well, those numbers are 4 and 6. So in factored form, this would be x plus 4 times x plus 6 equals 0. Okay? I can write upside down. Now, if I'm trying to find the solutions, technically you could use the 0 property and just say, okay, my solution for this first binomial is -4. My solution for the second one is -6. But I'm just going to go and take my time and actually set these up each equal to 0 and solve. So I'll say x plus 6 equals 0, I'll solve that, and then x, oh shoot, I made them backwards, whatever, doesn't matter. And then x plus 4 equals 0. So I'll subtract 6 from both sides on this first one. My first solution is x equals -6. Now I'm going to subtract 4 on both sides. And my second solution is x equals -4. Now, what that means is that my quadratic needs to cross the x-axis at -6 and -4. Okay, those are the two solutions. Now we know there's a lot of other critical information that goes on with quadratics. Like I could change this to vertex form and find where the vertex is. And I know that my y-intercept must be at 24. So a lot of information. I'm just focusing on where it crosses the x-axis. So just to do like a little sketch of this, I know it's going to be opening up because my x value, my a value, or my coefficient in front of x squared is positive, it's 1. So I really just need to get a sketch of where it's crossing. And so negative is that way. I'm going to the left. 1, 2, 3, 4. It's going to cross here. 5, 6. It's going to cross here. It's opening up. My vertex is somewhere around here. And it's increasing. That is not too bad for doing this upside down. Okay? I want to do one other example where your coefficient or where your a value is still 1. But it's one that throws students off a little bit because you're like, what is my c value? What if you have something like x squared plus 4x equals 0? Well, technically there's no c value being represented, but it would be 0. So I could say what two numbers multiply to be 0 and add to be 4? Well, that's going to be 4 times 0. 4 times 0 equals 0, and then 4 plus 0 equals 4. Another thing you can do is just look at your two terms. Anytime you have two terms, just say, what is their greatest common factor? Well, the only number that they have in common, the only thing they have in common is x. So I'm just going to factor out an x. And I'm left with x squared divided by x is x. And I bring down my plus sign. 4x divided by x is 4. So those are technically that's technically in factored form. I'm going to say x equals 0 for this first one. It's not in parentheses, but that is the first intercept. And then I'm going to say x plus 4 equals 0. And solve. Minus 4, minus 4. My two solutions are x equals 0 and x equals negative 4. Running out of space. Now, if I were to graph that, 0 and negative 4, I still know that it's opening up. I know that we have a y-intercept at 0 based on my standard form. And I'm just going to do a little sketch here. Nails. Okay. So 0, and then 1, 2, 3, 4. Okay? And I know my line of symmetry has to be exactly between those, so let's just say it's about there. And then it's increasing. Probably my worst quadratic shape or parabola ever. Okay. Let's do one example where your coefficient is not 1. Something like 3x squared minus 17x plus 10. Now, we've had a lot of practice on factoring, so this shouldn't stump you. But this is one example where you can't just look at the binomials at the end after you have it in factor form and switch the signs. All right? I'm going to switch out markers because I think this one is kind of dying. I only have 4 markers left at home, so hopefully it'll survive during this timeout. So I have 3x squared minus 17x plus 10, two numbers that multiply to be 30, 3 times 10, and add to be negative 17. Well, those two numbers are negative 2 and negative 15. Negative 2 times negative 15 is positive 30. Negative 2 plus negative 15 is negative 17. So I'm just going to write it in expanded form. I'm basically separating negative 17 into negative 15x, oh, this marker's much better, and negative 2x. And then I just bring down the plus 10. It's still equal to 0. And bring down 3x squared. Now, we have it in 4 terms. Oh my gosh, I match. Okay, distracted. This is called factoring by grouping. So I'm going to group the first 2 and group the next 2. 3x squared minus 15x. This is again where you're just saying what is the greatest common factor here? Well, the number they have in common is 3, and they also have an x in common. So I'm going to factor out 3x and then say, what am I left with? Well, 3x squared divided by 3x is x. Negative 15x divided by 3x is a negative 5. Okay? Next set. What can I factor out of negative 2x plus 10? Well, 99% of the time, if this is negative, we're going to factor out a negative number. So I'm going to say minus 2 or negative 2. And then what I have left is, negative 2x divided by negative 2 is x. 10 divided by negative 2 is negative 5. And that's still equal to 0. Now again, I love this method because if the binomials match, then you know you did this right. So my factored form is a combination of what you pulled out in the front, which was 3x minus 2 in parentheses times whatever's in the parentheses, x minus 5 equals 0. So now my two solutions, I'm going to say 3x minus 5, set that equal to 0. And we're going to solve that. Your second one is going to be x minus 5, set equal to 0. Add 5 to both sides for this one. I'm just going to do this first because it's a little faster. One of my solutions is x equals 5. The other one, I have to add 5 to both sides first. Then I have 3x equals 5. Well, I still have to divide by 3 on both sides. So if I divide by 3, divided by 3, my other solution is x equals 5. This is the best 3 ever. 5/3. Okay, so a little bit less than 2. Now if I were to graph that, it looks the same way, or you do the same thing. No, I'm gonna just do a rough sketch of that. I need to get rid of this information so I have enough space to graph. But again, this has 2 solutions. One of my solutions is at a positive 5. So 1, 2, 3, 4, 5. My other solution is a little bit less than 2. So 1, 2, I'm going to put it about right there. And my vertex has to be somewhere right in between. So it's going to be something like that. Okay? But the purpose of this was just so you know what I'm asking for. If I say solve a quadratic by graphing, and I would ask for the 2 solutions, one being 5, the other one, you can leave it as a fraction, 5/3. Okay? So I hope this was helpful. If you found it helpful, please like and subscribe. Rachel Teaches Math, and keep wearing monochromatic colors. All right? Peace.